G'day guys. Okay, so today we're looking at something called factorisation. Okay, so we're factorising. We use an S, you can see there, in Australia, but in most textbooks that you'll look at, because they'll be American, you'll see a Z there. But it doesn't really matter, I suppose. So our learning intention today is to simply learn how to factorise, and we do that by identifying the highest common factor between two terms. But none of this is making any sense to you, I'm sure, so let me explain what we're really doing. Factorising is the opposite of expanding brackets. In other words, it's the opposite of using the distributive property, which is what you learnt about last lesson. Okay, so let's just say we are given this problem and we're asked to use the distributive property to expand the brackets. Well, we would recognize that there are two things on the inside of the brackets. We have an L and a plus W, and then we would do 2 times L to get 2L, and then we would do 2 times plus W to get plus 2W. And we will have expanded the brackets, use the distributive property. We did heaps of those sorts of problems last lesson. All factorisation is going back in the other direction. So you're given a question like this and you're asked to bring the brackets back into play, okay, as opposed to get rid of the brackets. All right. Now, a really important concept when it comes to doing this is the highest common factor. So the highest common factor is the greatest factor that divides exactly into 2 or more terms. So for example, the highest common factor of 24 and 18 is 6, because that's the highest number that is a factor of both of those two numbers, okay? But because this is algebra, our terms aren't just numerical, okay? We're not just dealing with numbers, we're dealing with variables as well. So it's a little bit more complicated than that. Okay. So ultimately, we're going to be asked to factorize, which means put back into bracket form, things like, I don't know, 2x plus 6. 3a squared plus 9ab squared. Things like this, okay? But before we can do that, we need to know how to find the highest common factor of two terms, the two things that are going to be added or subtracted together. And this is because the highest common factor is the thing that will end up going outside the brackets. All right, so what is the highest common factor of 10x and 15x? Well, we can just consider the numerical part, the coefficient first. What is the highest common factor of 10 and 15? So HCF of 10 and 15, well, that's easy, that's 5. We've learned how to do this already. Okay, now let's think about the variable part of the two terms, 10x and 15x. What do they have in common? What factor in terms of the variables do they have in common? Because the numbers 10 and 15, the factor that they had in common was 5. 10 is 2 times 5. 2 times 5, and we have a times x, and 15 is 3 times 5. So 3 times 5 times x. Now, we've isolated or determined that 5 is part of the highest common factor because there is a 5 in common between these two terms here. Well, what else is in common? There is an x in common. All right. So the highest common factor is actually 5x. So that 5x is what will go outside of the brackets when you have factorized this problem, okay? Another way to think about this is when talking about numbers, and highest common factor, we often say, what is the highest number that will go into 10 and 15 without any remainder, okay? Well, in terms of the, so we're talking about division really. 10x and 15x, what is the highest power of x that will divide into both those terms? Well, let me just scribble over here for a second. Will x to the power of 1 divide into that? Yep, because they cancel out. Will x to the power of 1 divide into 15x? Yep, because they cancel out. So that means that x to the power of 1 is the part of the highest common factor that is the part that involves variables, okay? All right. So let's do the same thing over to the right here. 12ab and 18b, what is the highest common factor? Well, highest common factor, let's do the number first, of 12 and 18 is 6. Okay, so 12 is 2 times 6, and we have an a and a b, so times a times b. 18, well that's 3 times 6 times just a lonely b. All right, well 6 is in common on both sides, in both terms. I've already figured that out. What else is in common? Well, there's a 2 here, but there's no 2 on this side. There's a 3 here, but there's no 3 on this side. There's an a here, but there's no a on this side, but we do have a b on both sides, okay? So 6b. Have to make that purple. 6b, okay? So the highest common factor of 12ab and 18b is 6b. All right, we'll speed it up a little bit and do 2 more problems that are slightly more complicated, okay? So what is the highest common factor of these 2 sets of terms? Okay. Highest common factor. Well, 24 and 40. The highest common factor of 24 and 40 is 8, I believe. Okay, and you can, you know how to find that yourselves by writing lists of factors, okay? All right, now 8, well that's 24 is 3 times 8, and then we have times g times h times h. So g, h, h. I can't even be bothered putting the multiplication signs in. This is just scribble, this part here anyway. 40, well that's 5 times 8 times f times g times h. Okay. All right. So the 8 is in common between both terms. The 3 isn't. The 5 isn't. Now let's look at the pronumerals, the variables. I have a g to the power of 1, g to the power of 1, okay, which means a g belongs in my highest common factor. What else do we have? I have an f here, but I don't have an f in the left term, so there is no f as part of the highest common factor. And I have an h here, and another h here. So h is part of the highest common factor. Now we have something remaining. We have a second h. So why didn't I put h squared as part of the highest common factor? Well, it's because when we're trying to figure out the highest common factor, we're identifying things that are common in both this term and this term. They only shared one h in common, and that leftover one here just gets left out of the picture. So 8gh. All right, a second problem. 6c squared d and 8cd squared. Okay, well, let me change back to purple. What is the highest common factor first of 6 and 8? Well, that is obviously 2. Okay, so we have 2 times 3 times c times d. And 8 is 2 times 2 times 2 times c times d times d. All right. Now, we have a 2 in common, which is why 2 is part of my highest common factor. But you'll also notice here that we have a couple of extra 2's, all right? But if I were to include those in my highest common factor, they would need to match up with 2's in the other term as well, but they don't. So we forget about those. We have a 3 here, but no 3 in the right-hand term, so we forget about that. Here's a c that's in common, and they both have a single d in common. All right, so I can write those down. They both had a c in common, and they both had a d in common. But look what's remaining. We have a d over here, but no d on this side. And we have a c here, but no c on this side. So we don't add another d or c to the highest common factor. We get 2cd. Okay, time to use this now to actually factorize examples like this. So this is the sort of problem that we've been building up to. 5xy minus 15y. Factorize this problem. That's the instruction, to factorize it. Okay. Normally it wouldn't be split into 3 steps, but we're just learning how to do this. So I've broke it down here. Step number 1 is to find the highest common factor. Well, highest common factor of 5 and 15 is 5. What about x, y, and y? Well, both of those terms do not have an x in common, but they do have a y in common, so 5y. Now here's what you do. You put, oh actually I better do it in the order that they're asking me to. I was getting ahead of myself and I was just going to finish the problem. Okay, step 2. Place the HCF out the front of the brackets. Okay. Must mean something like that. There we go. And then step 3 is divide the terms, these things here, by the highest common factor, and that will tell you what goes here, and that will tell you what goes here. But let me explain that in a slightly different way. What do I need to multiply 5y by to get 5xy? 5y times something will give me 5xy. Well, 5y times x will give me 5xy. So we sort of put the leftovers in the brackets. I call it putting the leftovers in the fridge. All right. Now we have a minus sign here. So I'm going to put a minus sign here. Okay, 5y multiplied by what gives me 15y? Well, the y is already part of the 5y, so I just need the 3. And then we have it. The good thing about these is you can always check whether you did the right thing, because you just do the problem in reverse and see if you get back to where you started. 5y times x equals 5xy. 5y times negative 3 equals negative 15y. So that is how you factorize. All right, now just a few examples. I'll do these, well, I'll try not to take too long. Okay, 10x minus 30. So equals the highest common factor out the front of some brackets, and then the leftovers inside the brackets. That's how we're going to think about this. All right, 10x is our first term, minus 30 is our second term. Well, what's common to 10 and 30? Well, 10. And there's only a variable on the left-hand side, on the leftmost term there. So there isn't going to be a variable in the highest common factor for this one. Brackets, leftovers in the brackets. 10 times what gives me 10x? Well, 10 times x. 10 times what gives me negative 30? Well, it must be a negative, and it must be 3. There we go. 10 times x is 10x. 10 times negative 3 is minus 30. 10x minus 30. All right, question B. 4ABC equals, 4ABC minus 24BCD. Okay. Well, let's just deal with the coefficients 4 and minus 24. Highest common factor there is 4. All right, now we have ABC, all just powers of 1, and BC, D. So out of those two parts of those two terms, what is in common? Well, both of those terms share a C, and they both share a B. The left-hand term has an A, but the right-hand term doesn't, and the right-hand term has a D, but the left-hand term doesn't. So they share a C, and they share a B. Okay, so 4CB, but we put it back into alphabetical order, 4BC. Now we put the leftovers in the fridge. 4BC times what gives me 4ABC? Well, A. 4BC times A is 4ABC. 4BC times what will give me negative 24BCD? Well, it's going to be a negative, and the number will have to be 6. 4 times negative 6 is negative 24. We already have a BC here, so we just need a D after that, 6. Because 4BC times negative 6D gives us negative 24BCD. Okay. Couple more. 10C cubed minus 25C squared. All right. Well, what is the highest common factor of 10 and 25? That would be 5. Now, C cubed and C squared. All right, so I'm just going to scribble off to the side here. C times C times C is C cubed. C times C is C squared, okay? So what goes outside the brackets? Well, they both share one of these C's. Both terms share a second one of these C's, so C squared in other words. This third C is not shared by a third C over here. So the variable part of the HCF is C squared. Now we put the leftovers in the fridge. 5C squared times what gives me 10C cubed? Well, it must be 2C. 5 times 2 is 10. C squared times C is C cubed. Okay. Now, 5C squared times something gives me negative 25C squared. Well, 5 times negative 5 gives me negative 25. And I already have my C squared. So that's it. 5C squared times minus 5 gives me minus 25C squared. So bring that bracket in a little bit. That's the answer. All right, guys, I think this video is starting to take a little bit too long, so I'll get you guys to do question D on your own. And I'm sure you'll get the right thing. So that was factorization, guys. The opposite of expanding brackets, or the opposite of using the distributive property. That's the way that we want to try and think about it, okay? All right, thank you for tuning in, and I'll see you next time.